In this video, I will show you that structurally very similar chemicals could have different biodegradation. This difference could be explained by their metabolic dissimilarity. A metabolic similarity tool implemented in Catalogic allows comparison of the simulated metabolic maps between chemicals. Part 1 of this video addresses metabolic similarity between chemicals within the OECD 3.1c test protocol. The tool can explain the significant difference in the predicted BOD values for structurally similar chemicals as those shown in the working window. Let's investigate the metabolic similarity between these chemicals. This is the target chemical, and it will be compared with its analog according to the different metabolic similarity criteria: transformations, profilers, common metabolites. Let's compare these chemicals by their common structural features. For this purpose, we will use existing profilers available in QSR Toolbox. In fact, Catalogic is docked to QSR Toolbox, and the knowledge from Toolbox could be extracted automatically. In our case, the Organic Functional Groups profiler will be used as it is one of the most appropriate profilers for estimating the structural similarity between chemicals and their metabolites. The statistical comparison options could be in a fingerprint mode, taking into account presence or absence of structural features, or in a hologram mode, taking into account frequency of appearance of the structural features. The quantity option allows comparison of the structural features with respect to the amounts of generated metabolites. The analysis could be applied to all metabolites or those with amounts above specified threshold. As can be seen, these chemicals are structurally very similar. Let's explain the result. The bar diagram shows that almost same structural fragments appear in both chemicals. The difference is in the frequency of appearance of these fragments. For example, we have the same frequency of appearance of aldehyde fragment, whereas the frequency of appearance of isopropyl fragment is different in both chemicals. The metabolites with identified common structural features can be seen in the simulated maps of both chemicals. The high value of structural similarity does not answer our question why these chemicals have a big difference in the predicted BOD values. So let's compare the simulated maps of these chemicals according to their common metabolic transformations. All transformations are categorized into more general and more specific levels of description. For example, this is hydrolysis, and more specifically, alkaline salt hydrolysis. In our case, we will compare the simulated maps by frequency of application of the metabolic transformations. The similarity results show that the compared chemicals possess different metabolism, although they are structurally quite similar as parents. The bar diagram clearly shows that some of the molecular transformations that are happening in chemical 2 do not take part in the simulated metabolism of chemical 1, and the opposite. Other transformations, for example methyl group hydroxylation, that are happening in both chemicals have different probabilities of occurrence, and this will have consequences. The reason is that in case of chemical 1 we have a branched alkyl chain, whereas in chemical 2 the alkyl chain is linear. The difference in probabilities leads to the different amounts of the parent chemicals as shown in the distribution charts. Chemical 1 is really stable as a parent, whereas chemical 2 is exhausted as a parent at 28th day. Moreover, the probabilities the metabolites to be generated are different. Very low probabilities of generation of metabolites for chemical 1 and high probabilities of generation of metabolites for chemical 2. This explains the different amounts of the parent chemicals, and this is the reason for the conflicting predicted BUD values. In summary, both chemicals are metabolically dissimilar, which explain the difference in the predicted BUD values. This statement also holds for observed biodegradation data. We can conclude that the chemical 2 cannot be used as an analog of chemical 1 for read-across prediction. Thank you for watching this video. If you are interested in Catalogic, please contact us. The links will be below.